Let us solve another circuit. Things will inshallah be more clear after solving this circuit. And let us break the chains and move to something more complex than simple RC network. You have the circuit in front of you, the one in red color. Basically, I have chosen this circuit because there are 2 to 3 very good learning points in this circuit. We have a voltage source, a DC voltage source of 12 volts. We have a switch which is in position 1, and at time t is equal to 0 it moves to position 2. We have a resistance of 6 kilo ohms. We have a capacitor of 100 microfarads and another resistance of 3 kilo ohms. And it is required that the current through 3 kilo ohms resistance is required to be evaluated. So let us follow the simple steps. The switch is in position 1. Let us draw the circuit while the switch is in position 1. When the switch is in position 1, the source is connected to 6 kilo ohms resistance and capacitor and the 3 kilo ohms resistor. But there is one important point. At time t is equal to 0, or just before time t is equal to 0, t is equal to 0 minus, the voltage source, the DC voltage source, is connected to a circuit which has a capacitor in it. So what do you think? That before the operation of switch, the capacitor is connected to the source through a resistance. So it will be charged to its maximum capacity, right? So when it is charged to its maximum capacity and it is connected to a DC source. What is DC actually? DC is direct current, and DC is a constant value. It does not vary with time. So what would be the current across the capacitor? Will the capacitor allow any current to flow through it? No. Since I is equal to C dV by dt, so while V is constant, it is not changing with time. But the derivative of a constant term is 0. So there will be no current passing through the capacitor, and that is why capacitor is assumed to be an open circuit in case of DC. So in this case, while the switch is in position 1, the capacitor is connected to the source and it is charged to its maximum capacity, whatever it is, and it will behave like an open circuit to the DC. So our analysis becomes very simple. We will replace this 100 microfarad thing with an open circuit, and the only things left behind will be the voltage source, the 12 volt voltage source, the 6 kilo ohm resistance and the 3 kilo ohm resistance, and the voltage Vt, which is now the voltage across 3 kilo ohms resistance. Since the capacitor is now open, it will be equal to 3 divided by 3 plus 6 into 12. Simple, the voltage division rule is applied and it will come out to be 4 volts as shown in equation 1. So while at t greater than 0, what will happen? At time t is equal to 0, the switch moves from position 1 to position 2 and it will remain there at time t greater than 0. So now the source is disconnected from the system, right? So the new circuit will be the 6 kilo ohms resistance connected to the capacitor, and that is connected to the 3 kilo ohms resistance. All these three things are in parallel. The node voltage is V of t. Let us simply write the node equation. It will be V of t divided by 6k plus 100 times is C, simple, the C dV by dt thing, 100 microfarads multiplied by dVt by dt, and V of t by 3k. So let us simplify this equation. Simplifying this equation will give us Equation number 3, dv by dt plus 5 times dt is equal to 0. Now look at this equation number 3, and try to bring that homogeneous thing into your mind. This is simple homogeneous equation. So if it is a homogeneous equation, since its right hand side is equal to 0, there will be no k1, right? There will only be the natural response. There will be no forced response. Since the source is disconnected, there will be no forced response. There will only be the natural response. And while there is only natural response, since it is a homogeneous equation with the right hand side equal to 0, you don't need to worry about k1. There is no k1, right? There is only v of t is equal to k2 times exponential of minus t over tau, the solution to the homogeneous equation. And it is written in equation number 4. So using this value of v of t of equation 4 in equation 2, let us wait for Azan to end. So let us resume the analysis. So we were on equation number 4. As I said that it is a homogeneous equation, there will be no k1. We'll only be dealing with the solution v of t is equal to k2 times minus t over tau. So putting this value of v of t of equation 4 in equation 2, or simply equation 3, yields k2 times exponential of minus t over tau times minus 1 over tau, so we are simply taking the derivative, plus 5 times k2 exponential of minus t over tau is equal to 0. This is equation number 5. Simplifying this equation gives us the value of tau, which is equal to 0.2 seconds, right? So now again, employing the initial conditions, we performed in the first step. Yes, in the first step we performed the analysis for t is equal to 0. At time t is equal to 0, v of t is equal to 4 volts. Using this value of v of t at time t is equal to 0 in the solution of equation 4 gives us 4 is equal to k2 times exponential of 0. Exponential of 0 is equal to 1. Therefore k2 comes out to be 4. So finally the value of v of t comes out to be 4 times exponential of minus t over tau, or 4 times exponential of minus t over 0.2. And simply the current I of t which was required to be evaluated is v of t divided by 3k. So it comes out to be 4 by 3 exponential of minus t over 0.2 milliamperes. So if you want to draw this, the response, simply write time for the, if you want to draw the response of current, the waveform of current, see the value of at time t is equal to 0. At time t is equal to 0, this value of current comes out to be 4 by 3. So mark 4 by 3 on the y-axis, and since it is a decaying exponential, minus t over 0.2, draw decaying exponential which is ending in the x-axis. I have drawn it for you. This is the simplest technique to draw the response, right? Thank you very much. Assalamu alaikum.